One of our biggest topics that we're getting into is going to be the linear equation. So this is the start of it. So linear equation is a line. So we're looking into the algebra, what causes it to be a line. That has to do with the constant rate of change, that kind of stuff. But for this first assignment, we're going to try to determine if a point is on a line. So what does this line even represent? When you look at the graph of a line, it represents all the points that make the equation true. So we're going to be testing which of these points make the equation true. Now there's an infinite amount of points, if I were to put it on Desmos, and I'll show you that in a little bit, that would make this equation true. But let's go ahead and just show you algebraically, how do we test these points? So we have 2x plus 3y equals 10. So for this first point, 2, 2, I'm going to plug a 2 into the x and then a 2 into the y. So I'll have 2 times 2 plus 3 times 2, and we're going to see if it equals 10. So 4 plus 6 is 10, and that is good, so that checks off. So yes, this one is good. So 2, 2 works. Let's go ahead and try now 1, 3. So x is 1, 3 is y. Let's substitute that in. 2 times 1 plus 3 times 3 equals 8. So we get, or not equals 8, equals 10. What am I thinking? 8 here. So 2 plus 9 equals 10. So 11 equals 10. And that is not true. So this one does not check off. So that one is bad. So we're just going to go with A, only 2, 2. Now let's go ahead and take a look at the graph real quick before we look at another problem. So I'm going to enter 2x plus 3y equals 10. Put projector mode so we can see it a little better. Okay, so this right here, there's an infinite amount of points that are on this line. There's an infinite number of points you can plug in here that will make this equation true, and that's what this line represents, is all of those points. But we're just looking at particular points to determine if they're on the line. So let's just graph each one. So you could use Desmos for this. I would recommend do it algebraically first, and then double check your answer. So here we can see 2, 2 is on the graph, but what about 1, 3? And there, if you look, you can already see it's not on the graph, so that's not good. So that one doesn't work. And here's a very similar example you could work through. I want to work through one of these. It's in point slope form. So we have y minus 3 equals 5 times x minus 2. And so just to test it, let's test 2, 3 first. So 3 is the y. I'm just going to label this real quick. So we have 3 minus 3 equals 5 times 2 minus 2. So we get 0 equals 5 times 0. So 0 equals 0. That checks off. That's good. Now let's go ahead and try the point 3, 2. So this time x is 3 and y is 2. So we're going to have 2 minus 3 equals 5 times, and then x is 3 minus 2. 2 minus 3 is negative 1 equals 5 times 1. Negative 1 does not equal 5, so this one does not work. So once again, we see that A is the only answer. So you could try those others. We'll try those in class. That should be enough there, though. Hopefully you got the main idea. Plug in the x, plug in the y, and see if it's true.